Assalamualaikum warahmatullahi wabarakatuh. We are from Department of CTS, Kuliah of Science. So, we will be conducting an assignment entitled is the drug concentration in two compartment system for the subject SMS2411 Advanced Mathematical Method. So, we are from group Misi Mustahil and our instructor are Dr. Farah and Dr. Amira. So, the related scope in this topic is about the pharmacokinetics, which is it involves the study about the rate of absorption, distribution, and elimination process of drug concentration within our body. So, firstly, we will study and try to calculate the rate of drug concentration infused from blood to tissue. And secondly, we will study the rate of drug concentration diffused from tissue to blood. So, we have two objectives that we want to achieve in our study. Firstly, we want to solve the differential equation of the drug concentration in two compartment system. And secondly, we want to determine the concentration of drug distribution between two compartment system. Enjoy!
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Saiful Hasib bin Abdurrani. I will explain to you about our mathematical model. Our mathematical model is actually a mathematical explanation about the movement of drug in an animal's body. For this pharmacokinetic study, we have specified into a specific example, which is the administration of a drug called salicate into the rabbit's body. This mathematical model explains about first the absorption, which means the passage of the drug from the administration site to the rabbit's blood. Second, the distribution, which means the passage of the drug from the blood to the rabbit's tissue. And third, the elimination, which means the passage of the drug from the blood of the rabbit to outside of its body. Hence, we have chosen our mathematical model to be like this, in which it is made up of an initial value problem which consists of two first-order linear ordinary differential equations and two initial conditions. A1t is actually the drug concentration in the rabbit's blood with respect to time, and A2t is actually the concentration of the drug in the rabbit's tissue with respect to time. K12 is actually the rate of flow of the drug from the rabbit's blood to the rabbit's tissue. K21 is the rate of flow of the drug from the rabbit's tissue to the rabbit's blood, and K10 is actually the rate of elimination of the drug. However, to make our calculations later easier and for us to easily plug in all these equations into the computer, first we let A1t equals to xt, A2t equals to yt. Second, we factorize all the terms on the right side of these equations. And third, we plug in all the constants that we have because we already specify on a specific example, so that we can have a new form of initial value problem, which is like this.
So we move to the manual solution of our mathematical model. So this is our first equation, this is our second equation, and this is our initial condition. So first, we perform Laplace transform on the both sides of our first equation. So we get this. And then we substitute the initial condition, we get this. So we make this as one term, so we choose xs as our term. So this is first. So we move to the second equation. This one, we perform Laplace transform on the both sides of the equation. So we do same as the previous one. So we substitute the initial condition, so we make it as in the term of xs2, so we get this. And then we compare both of the equation that we get from previous. So we compare, so we make it as one term only, which is ys. So we get this. After we get this, we need to inverse Laplace of the equation, but we cannot directly inverse Laplace the equation, so we must perform partial fraction. So we make partial fraction for the equation, so we get this, which is the A value is 54.0197 and B is negative 54.0197. So then we perform inverse Laplace on the both side of the equation. So we get the equation, first equation yt, and then we differentiate that equation to find our xt. So we move to the next step, which is to find the xt equation. So from the derivative of function yt, so we compare with this one to find xt. So we bring xt to the one side only, so we get this equation. So this is our final answer for manual solution.
Next, we move to the computer aided solution. We use Maple to solve our equation. This is how our Maple coding for the problem. This is how we get x with respect of t, and this is how we get y with respect of t.
About the interpretation of our results, which are divided into two. The first is the comparison between our manual solutions and computer-aided solutions. Our manual solutions have a bit different answers, but if we round off to 2 decimal places, they will be the same. The next interpretation of our results is by representing our solutions into graphs. We have xt, which means the drug concentration in the rabbit's blood with respect to time, and yt, which means the drug concentration in the rabbit's tissue with respect to time. As the time goes by, we can see that xt is lower than yt. This is because the level of drug in the blood is lower than the level of drug in the tissue, which means the elimination process occurs and the diffusion of drug from blood into tissue also occurs.
To conclude, from the value of x with respect of t and y with respect of t, we can know that the drug concentration in blood is lower than the drug concentration in tissue, as drug easily diffuse into blood than the tissue.